All right, so let's actually try an example. So we're going to do a bit of probability. Don't get scared. We'll walk through each specific step. But remember, so we're going to do this with one single nucleotide polymorphism. So essentially, we do these analyses via computer, thousands to millions of times. And so we're gonna calculate it by hand one time. I'm going to have you do an example. But just keep in mind that we have computational tools that allow us to do millions of SNPs across the genome. And so what we're investigating today is the ability to, the bitter taste ability, the ability to taste something bitter. And you see our genotype counts here. And so this is with an N of 36 people. So you see 2 people are homozygous for the A allele, 4 people or 2 people cannot taste the bitter taste and are homozygous for the A allele, for being able to taste bitter tasting things and being homozygous for the A allele and so forth. And this is at SNP X4988235. And so what we first do is we get observed allele counts. And so we just basically, count up the versions of the particular SNP that those individuals have. And so for our AA homozygotes, they have 2 copies of the A allele, and so each one of those people get 2 A's. For our heterozygotes, they get 1 A, and then for our GG homozygotes, obviously they don't have any A alleles. And then conversely, we can work through 1 G allele for our AG heterozygotes and 2 Gs for our GG homozygotes. And you see that we total up in our 2x2 contingency table for our A allele and our G allele being bitter tasters and non-tasters. Once we have our observed allele counts, we then convert this into frequencies, right? And so we divide this by the total number of alleles in our overall population. And so we get our percentages, pretty easy to do there. And then what we calculate is our expected frequencies and determine our expected counts. And so here's our example contingency table from our last step up top here. And what we're doing here is we're treating each event as independent, and we're calculating our contingency table. And so we're looking for the probability of being a bitter taster given allele A, and that equals the probability of being a bitter taster, which is our overall probability here, which is 0.667, multiplied by the probability of inheriting the A allele, our total being 33.3. And so you see 0.667 times 0.333 gives us our expected frequency. And we can go forward and we can calculate each of these. So for example, if we're looking for non-tasters, right, so we take the probability of being a non-taster, which is 33.3, so 0.333, and then multiplied by the probability of carrying that A allele, which is 33.3. We see it multiplied by 0.333 gives us that 11.1%. And once we've filled out our 2x2 contingency table, getting our expected frequencies, we then convert this into our expected counts. And we now have all of our values to use our statistical test. And the statistical test that's often used is called the chi-squared distribution. And basically, chi-squared is observed minus expected squared over expected. right? And so we have all of these values that we've determined in our contingency table here. And so you see this written out with all the things that we've determined thus far. And so that gives us a chi-squared value of 0.3. And we could then go to a chi-squared calculator. I've included one here that you can click on. You should be able to go to. Enter in our 0.3 value using a 1 degree of freedom, and it should give you a p-value of 0.58. Now, in order to, okay, so what does, answering the question, what does a p-value of 0.58 mean? And so we want to see if, there is a statistically significant relationship with, between a genotype and phenotype. We want this p-value below 0.05. And so because it's above 0.05, we can say that there's no statistical relationship with this particular SNP related to bitter tasting or not being able to taste bitter things. But if for example, our expected and observed values gave us a chi-squared that gave us a p-value below 0.05, we would say, yes, this SNP is statistically associated with being able to taste bitter things. And so now I want you to try it. And so we've gone through an example in the previous slides. And so here is new SNP data, new genotype counts from our 36 individuals. And I want you to show your work in a Word document. And so develop those contingency tables, develop the observed and expected values, and calculate out that chi-squared value. Go to that online calculator, enter in that information, and give me back the p-value and whether or not this particular SNP is associated with being able to taste bitter things. And you can turn that in anytime Tuesday before midnight. So we have a few days to do that. So go ahead and practice a little bit of math, practice a little bit of determining statistical significance using the chi-squared distribution, and we'll move forward with our next lecture on Tuesday. All right, thanks guys.